By the way, if you have not taken the term, please contact me as soon as you can so that I can schedule a makeup for you. Let me take just a few minutes to make sure that everybody has a basic understanding of games. In part because you will need this for the final, but also because it is practical in real life. So this is just the historical background on games in economics. So game theory, although it has been developed now for about 50 or 60 years, really is a basic trend only in recent decades in economic programs. So here is the structure of a game. Many of you are already familiar with this. If you would indulge me for a few moments to take to students who are not familiar with games. In the upper left-hand corner, we list the players, player 1 and player 2. In this case, player 1 is Peanut, and player 2 is TDTU, our rival. For player 1, the strategies are always listed in rows. In this case, Peanut can either pursue high position or low position instead. And then for player 2, the strategies are listed in columns, not in rows. To take it to you, high position and low position. All these in the cells of the matrix are the payoffs to each player. And always the first payoff is to the first player, and the second payoff to the second player. So, for example, suppose the Peanut chooses high position and TDTU chooses low position. Then Peanut will receive 3 points and TDTU will receive 0 points. And there is a summary of our discussion. So you have to be a bit careful because sometimes students confuse the rows with the columns. The columns are always strategies of the second player. There is the summary so far for our discussion. Okay, so how to solve the game? Let's begin with player 1, and then we will take as given the strategy of player 2 and determine what Peanut needs to do to increase his payoff by choosing a particular strategy. So, for example, if TDTU is assumed to the high position of the payoff to Peanut or higher if it too chooses high tuition as opposed to low tuition. So here we are looking at CNET's decision. CNET will decide which strategy to pursue. The teaching is given the strategy of its rival KTTU. If KTTU chooses high tuition, CNET will do better by selecting high tuition as well. One is greater than 0. And then CNET will also consider what to do if instead of high tuition, KTTU chooses low tuition. So in this case, what will CNET do? Well, 3 is better than 2. Remember that the first number is the payoff to pair 1 CNET. So CNET, given that KTTU is choosing low tuition, will do the choose high tuition instead. Okay, so far. So it's a good idea to mark the best response as you're running along. If KTTU chooses high tuition, so will CNET. So let's put an asterisk by that choice. The other possibility the CNET must bear in mind is that KTTU could choose low tuition. In that case, CNET does better with high tuition rather than low tuition. So let's put an asterisk next to that best response, the CNET to low tuition from KTTU. Okay, so far. Please stop me or send me a message to chat if anything is not clear. So now we're going to take a look at KTTU. In this case, when we are trying to decide what KTTU should do, we will look at the roles, since it is the role that gives the strategy assumed from CNET. So, for example, if CNET charges high tuition, KTTU will do better to charge high rather than low tuition. 1 is better than 0. So put an asterisk by KTTU's response of high tuition. And already you can see that we have a solution to the game. Now, suppose instead that CNET charges not high tuition, but low tuition instead. what should you do in that case? I will give you a moment to look at the game and for 1 point of extra credit, suggest the best response attributed to you to world tuition from Tina. Remember that the payoff the KDTU is given by the second number in each cell. So if Tina charges world tuition, KDTU can receive 3 points by charging high tuition rather than world tuition. So the best response to KDTU to the rivals world tuition is to charge high tuition. And there is the complete analysis of the game. So we have one Nash equilibrium since both responses are the best response given what the rival is doing. So that is the unique solution to the game. So let me summarize that analysis on the whiteboard. There are players, excuse me. Here are the strategies of Tina in volts, and then the strategy continued to use is in columns. And there are the payoffs maybe in terms of millions of dollars. In this game, they found that high conversion is a best response to each player given what the other player is doing. So if TDTU chooses high conversion, Tina's best response is also to choose high conversion. And if Tina chooses high conversion, TDTU's best response is also the perpetuation. So perpetuation from both pairs is a mass equilibrium. Remembering that this is the best that a pair can do, given what the other pair is doing. First is about the mass equilibrium in this case. Okay, good. So let's move on. Here is a new day for you. Being in the news. And there is the game. Ukraine is the first player and Russia is the second player. Why don't you take a moment or two to solve the game for 2 points of extra credit?
Like for the first, we should define. We should give our answer right now or later.
No, go ahead. And
Uh,
now
for,
it's fine.
for the first, we should define our first participant. For example, it would be Ukraine, I think. So we will see Ukraine steps by rows.
Yes,
Um,
good.
yes, and for example, if we will assume that Russia will decide with war, so for Ukraine, it's better to have negotiations. If we will have if we will know that Russia will go with the negotiation, for Ukraine, it would be better to have again negotiation. So we can see that whatever Russia decides, Ukraine also choose a negotiation way. So maybe Ukraine has a dominant strategy. Let's see what Russia has. If we will, for example, freeze Russian actions, and we will see the steps by columns of Russia. It's the second figure in our cells. If we will consider that Ukraine will choose war, for Russia it would be better to have war again. If Ukraine goes with negotiation, for Russia it would be better to have war again. So we see that whatever Ukraine decides, Russia always decides war. So there are two dominant strategies for Ukraine and for Russia. So it's Nash equilibrium also we have here, because we have two dominant strategies. And the Nash equilibrium, I think it's negotiation and war, right? Like 2 and 2. Yes, exactly.
Yeah, good. Good summary of the analysis. But I would note that a Nash equilibrium need not involve a dominant strategy. As you may remember from our example of the Davis dilemma, whether to go to Alpha or to Cold Park. In that case, this was not the dominant strategy to pervert mass equilibrium. But just the solution to this then is for Ukraine to negotiate and Russia to go to war. So the point is that you can use game theory to analyze issues in the news. When I designed this game, I knew and know very little about the foreign policy of Russia. But regardless of how much or how little you know, game theory will give us a systematic way of thinking about the problem. So here are the expected projects that you can try in the next couple of weeks. From your favorite newspaper, make predictions about controversies in the news. So, for example, in this game that we have just analyzed, the players for Ukraine and Russia, the actions, the negotiation and war, and the chaos are driven in the matrix. One thing to note, it may not be the case that both players have the same strategies. The strategies may differ, and that's fine. Okay, so far, good. Here is another game for you to try to analyze if you've not done so already. So I will provide 3 points of extra credit to whoever solved this game first. If there is a solution.
Maybe no.
Let's take a look. So maybe this game will be easier to follow on the whiteboard. So previous this time event and the United Nations event is trying to decide whether to develop missiles this month or not. And the UN is trying to decide whether or not to inspect the military facilities of Iran. And here are the chaos in terms of political points. Okay, go ahead with your analysis. What is the first step? Let's think about the team from the point of view of Iran. So Iran is thinking about what to do in either of two cases. Either UN that does not inspect, UN that does inspect military facilities. So suppose that the UN does not inspect. What should Iran do in that case? Well, one is better than -1. So that is one best response by Iran to the UN's failure to inspect. Let's suppose that the UN does inspect. What now should Iran do? For a point of extra credit? Well, one is better than -1. So Iran should not build missiles if it is being inspected. At least not to build missiles that month. So the best response to the U.S. decision to inspect is not to provide missiles at that time. Okay, so let's turn now to the U.S. decision. Remember that Iran's strategies are involved now, as opposed to the UN strategies which were in columns. So suppose that Iran does not build missiles this month. What should the UN do? Well, one is better than -1, remembering that the UN's payoff is the second number. So there is no best response. And then finally suppose that Iran does build missiles. Of course, in that case, the UN should inspect one being better than -1. Okay, so the $64,000 question is, what is the outcome of this game? What do you think? We see that there is no combination of strategies by the two players that are both best responses. So there is no mass equilibrium in actions. No pure strategies can solve the game. Why is that the case? Why was it so easy for us to find solutions to the other two games, but not to this game? But basically, it's a digital sum game. So, for example, given that the UN does not inspect, we're going to build missiles. So that's the best response. However, given that Iran built missiles, the UN should inspect. So missiles not inspection is not a mass equilibrium. And the same thing is true for all three other possibilities. Okay, so far. But before we do this next step, let me give you a moment to look at the notes so far. And answer any questions that you may have about them. Okay, no questions so far. Good. So there are the results that we have just analyzed. Had there been a mass equilibrium, then both payoffs would have had an asterisk. There is a summary of our analysis so far. But this is a very surprising result because we know from mathematical theory that every game has an odd number of mass equilibria. So although there is not a solution in terms of actions, build a missile, for example, or inspect, there is a solution in terms of the probabilities of the actions. And here's why. Maybe the players will try to outfox the rival by flipping a coin and then decide what to do. So let's see how to find the next strategy in this case. And then we can take a look at question number 5 on the quiz. Had the expected value been better, for example, for the UN to inspect rather than not inspect, inspection would have been part of the solution to the game. But there was no solution, so it must be the case that the expected value of this action is the same. And then just to remind you that an expected value will multiply the value of this outcome, that is probability. And there is an example. Okay, so far. So let's go back now to the whiteboard. We want to estimate the probability of building missiles and the probability of respecting that will provide enough equilibrium. We know that for each player, the expected value of both actions is the same. So this computes the expected value to Iran of not building missiles and of building missiles and then equates the two values to calculate the probability of inspection. Call the probability I. Okay, so far. Then with the expected value to Iran of not building missiles. So this will use the tails in the first row. First, suppose that the human does not inspect, that occurs with a probability of 1 minus I. In that case, the one will suffer a loss of a point if it does not take advantage of that lack of inspection of the building missiles. And then the other possibility is that the human does inspect with a probability of I, 10 or 15%, whatever. If that occurs, one will receive 1 point. So the expected value of not building vessels is I minus 1 plus I with 2I minus 1. Now for 3 points of extra credit, stresses it now, the expected value to Iran. Of building missiles. I will give you a little bit of think about the problem. So let's see how you did with this problem. The expected value of building missiles is in the second row of the matrix. Begin with the case in which human built up the step. The case occurs with probability 1 minus I. In that case, the vote will receive 1 point. The second possibility is that the human does inspect with probability I. If that happens, and Iran has built missiles, it will lose 1 political point. For 1 minus I minus I, for 1 minus 2I. Okay, so far. Remember that the expected value of the strategy that are wrong. So missiles or not. Let's do the same. So 2I minus 1 is equal to 1 minus 2I. So what is the value of I? So 1 point of extra credit. I equals 1/2. But must also be the same for 1 minus I. So there's a 50-50 chance that one a bit driven for the step. So if there's an equilibrium for the rhythm to try to fool around, that's the idea. would be so fun in the game. And for extra credit, the birthday determines the probability that Iran will build missiles. Quote the probability M. In a hit is calculated that we will need to compute the expected value to the UN of inspected or not inspected. Okay, so far, any questions about how to calculate a conventional mixed strategy? Okay, good. So let's take a look now at problem number 5 on the quiz. We now have two players, Dimitri and Urbana. Other one can study chemistry and study physics. And those are the only two possibilities. And then the payoff looked very strange all this one. So we already know that there are 4 pure strategies that will solve that game. So what we now want to know is whether there are any mixed strategies that are possible. So let's see, denote the probability that Dimitri studied chemistry is TD. But the only other possibility is that Dimitri could study physics instead. of 1 minus CD. Of the probability that statistics denote that as TD. Okay, so what is the accepted value? Sorry about that. Okay. To Dmitry, of studying chemistry, of the focus of affairs, let's consider the expected values to arena of studying chemistry or physics. So this will give us the probability that the nature studies chemistry. Okay, so what is the accepted value to arena of studying chemistry? So we're looking at this first column right here. That value is the TD, the probability that the nucleus studies chemistry, and in that case, Ravenna will receive 1 point. So maybe they're studying together. The other possibility is that the nucleus studies physics, not chemistry. With the probability of 1 minus CD, and then Ravenna receives 1 point. Or CD plus 1 minus CD equal to 1 with an accepted value. Yes, let's compute the accepted value to arena of studying chemistry and physics better than chemistry. So now we're looking at the second column in the matrix. One possibility is that the nutrient is studying chemistry is the probability of CD. And if so, the result will receive 1 point right there. Or the nutrient is studying physics instead. With the probability of 1 minus CD Remember that CD is a probability that he is studying chemistry. And then with a payoff of 1 right there. So CD plus 1 minus CD has the value, the expected value of 1. And then finally, it takes the two expected values. And we get 1 is equal to 1. So what probability or probabilities of Dimitri studying chemistry will solve the problem? You can take a moment to think about that problem for extra credit. Any ideas? Any probability of TD is consistent with a solution that 1 equals 1. There is an infinite number of solutions. And that is the solution to the problem. So the main point that I hope to bring away from this discussion of mixed strategies so first, to solve for pure strategies. And then to find a good strategy solution. But in thinking the expected values of actions for each player. Remember that to find the probability of an action to kill one's action you will need to calculate the expected values to pair number 2. For example, in the run Buren game, we found the probability of an inspection for calculating the expected values to use the Iran of building missiles. I will copy that last point over here so that you can see it on the screen. Just a tip in this case. And here's an extra project that you can try for Wednesday. And calculate the probability that the rate of study physics. And that is it on mixed strategies. Any questions about how, in principle, to solve for a mixed strategy? Really just a matter of formulating expected values of actions, and that's all. Other questions?